Hi, we're going to continue on with the algebraic logistics of working with polynomials. And the focus today is on synthetic division and long division. We will eventually get to apply this to our graphs, and it'll help us graph even bigger and better things. So if you look at example 1, it says to use synthetic division to divide. If you're told to divide by x minus 3, then you're going to solve for x and put that value inside the box. So whatever you put inside the box will always be opposite of this sign over here. Now you're going to take the leading coefficients in order. So you're going to start with 1 because that's x to the third, then 5 because that's x squared, then negative 12 because that's your x term, and then negative 36 because that's your constant term. So you're going to list the coefficients. You're going to draw a line, and to start your division, you drop down that first number. Whatever you put down here below the line, you multiply by what's in the box. So I'm going to take 1 times 3, and I put that answer here. Then I want to take my columns, and I want to add my columns. So 3 plus 5 is 8. That's below the line, so I multiply by what's in the box. Fill it in here. Negative 12 plus 24 is 12 because I add my columns. 12 is below the line, so we multiply by what's in the box, fill it in, and then last but not least, we add this column. Sometimes you're left with 0, and sometimes you're left with something that's not 0. So now what you're going to do is you are going to realize you got to fill in your x's. This started out an x cubed. Well, you divided by an x. So the exponent will always drop down 1. So if it is an x cubed and you divide it by x, that is now an x squared. This is a positive 8, so we need to put a plus sign. And now we list our x's with the coefficients out in front in descending order. This is a positive 12, so we put a plus 12. So our final answer here is x squared plus 8x plus 12. That's what we got when we divided. In the next example, we're taking the exact same function, but this time we're told to evaluate when x equals 3. So those directions mean we need to basically find f of 3 by plugging in a 3 and doing the math to find the y value. So that gives us 27 plus 3 squared is 9 times 5 is 45 minus 36 minus 36. When we add all those together, we get 0. So f of 3, because 3 is what we plugged in for our x value, equals 0. So what I want you guys to recognize here is in both of those examples, we took the same function. In the second example, which I'm putting a star by right now, we plugged in 3 for x, and we got a y value of 0. In the first example, which I'm putting a smiley face by right now, we plugged in 3 for synthetic division, and we got 0 for a remainder. What that tells us is that 3 for x and 0 for y provides us with an x-intercept. If we get a remainder of 0, whatever we put inside the box is an x-intercept of the function. So if you want to use synthetic division to help you find an x-intercept, or in this next example, a solution, because remember x-intercepts are solutions, then you can plug 2 inside the box, do synthetic division, and if you get 0 for a remainder, then that will tell you 2 is a solution. So that brings us to the remainder theorem. The remainder theorem says if the polynomial f of x is divided by x minus c, then the remainder is f of c. So what I want you to notice right here, that this usually is our x value. If you solve for x in the x minus c, you would add c to both sides, so that's why it is c. So whatever you have in your factor, you do the opposite of it to get your 0. So now let's wait for the bell. Okay, now here's what I want you guys to do. I want you to take this function and I want you to graph it. It's a cubic function, so graph this on your calculator. I'm going to give you a few minutes, probably about a minute to do that. Or you can press pause and I'm going to continue. When you graph this on your calculator, you should see that the x-intercepts are 3, -6, and -2. What that means for you in function notation is that f of 3 equals 0, f of -2 equals 0, and f of -6 equals 0. Remember, function notation, as you see it written right here, is the same as having a point with an x value of 3 and a y value of 0, or an x value of -2 and a y value of 0, or having an x value of -6 and a y value of 0. If the x-intercepts of the graph of this cubic function are at 3, -6, and -2, then the solutions of the equation have to also be at 3, -6, and -2, because x-intercepts are also called solutions. X-intercepts and solutions are also called zeros. So if the x-intercepts and solutions are at 3, -6, and -2, then the zeros are at 3, -6, and -2. Remember, x-intercepts, solutions, zeros, and roots all mean the same thing. If your solutions is at 3, then your factor would be x minus 3.
Sam Brunsman, Olivia.
If your solution is at -6, then your factor's at x plus 6. And if your solution is at -2, then your factor is going to be x plus 2. Your factors are always opposite signs of your solutions. Now, let's go back to this here. If we have zeros at 3, -6, and -2, then in function notation, that means f of 3 equals 0, f of -6 equals 0, and f of -2 equals 0. I didn't do a lot of different math with any of that, but I had lots of different terms. So you guys need to make sure that you're studying your vocabulary and you know what everything means so that you can apply this math and these concepts to those different words. When we're talking factors, you got to remember that if a solution A root, an x-intercept, or a zero of a function shows you that f of c equals 0 in function notation, then that means x minus c is your factor. And you can also say that if x minus c is the factor, then f of c equals 0. Okay, turning the page. Next thing we're going to talk about and review is long division. So with long division, what you have to remember is that you have a dividend that usually is your numerator. You have a divisor that's going to be your denominator. After you do the division, you have a quotient that is your answer. And sometimes you're going to have a remainder. But we don't write a remainder as like we did in middle school or elementary as r or something. We have a special way that we have to write our remainder with polynomial functions. So you're going to see a function on top and a function on bottom. When you divide those, you're going to get another function that is your quotient, and you add the remainder to the quotient by putting it as a fraction over your divisor. So let me label some of these things. Okay, your dividend is right here. Your divisor is the denominator. Your quotient is your answer. And then your remainder is always put over the divisor in your final answer. All right, let's do this division. You can't start the next problem until you have simplified this. So the quantity x minus 1 squared is the quantity x minus 1 times the quantity x minus 1. You're going to have to FOIL that out, and that ends up giving you x squared minus 2x plus 1. Since that's in the denominator, that is your divisor. When you're working through long division, remember you have a box. Your divisor goes on the outside. Your dividend is your numerator, and that goes on the inside. To start your division process, you're going to look at the first terms only. And you're going to divide. 2x cubed divided by x squared is 2x. You're going to put that on top. Whatever you put on top here has to be multiplied and distributed by whatever is part of your divisor. So I have to distribute to that trinomial. So I'm going to take 2x times x squared, which is 2x cubed. Those terms should always have the same sign. Now I'm going to take 2x times negative 2x, which is negative 4x squared. Those terms do not have to have the same sign. It just happened to work out in this problem. Then I take 2x times 1, which is 2x. After this step, you're going to draw a line, and then you have to subtract everything that you just put on that line. So that means you're going to have to distribute this negative. So you're going to have to subtract the 2x cubed. Subtracting a negative 4x squared makes that positive, and then this positive goes away, and you're going to subtract the 2x. By doing this, this first term will always cancel out. In this problem only, the second term canceled out. That doesn't always happen. Then you combine like terms, so negative 15x and negative 2x is negative 17x, and then we have plus 5 that drops down. When this term's power becomes smaller than this term's power, the x squared, you're done. So we can't do any more with this, but we have something left. So that something left is our remainder. So to write our answer in the blanks up above, because the directions say state the quotient is just the 2x. The remainder is the negative 17x plus 5. But to actually write your answer, you're going to write it as 2x plus negative 17x plus 5, because that's your remainder, over whatever you divided by, which is the quantity x minus 1 squared. And you can go back to the original problem to see what your divisor was. That's your final answer. Let's try this one more time. Notice on this example right here, we went from a 6x cubed to a negative 3x squared to a nothing with the x term. So I left a blank in your notes. You can also put in a plus 0x there, because when you're talking your dividend, which is what's going to go underneath the long division box, that always has to be listed in descending order, and you have to put zeros in for the missing terms. All right, so we're going to start out by dividing. We need to divide 6x cubed by 2x. So 6x cubed divided by 2x is 3x squared. Whatever you put on top has to be multiplied by whatever is out in front, which is your divisor. So 3x squared times 2x is 6x cubed, and 3x squared times negative 5 is negative 15x squared. After you do that, you are going to subtract both terms, which changes the signs. So don't forget to change the signs. That will also cross out the first term. You combine like terms here, which gives us 12x squared, and you drop down the 0x. Or you drop down nothing. So now you're going to do 12x squared divided by 2x. And that is 6x. So now you have to distribute the 6x to the 2x minus 5. So 6x times 2x is 12x squared. 6x times negative 5 is negative 30x. And now we have to subtract. Remember, when you subtract, you change both signs. The first term's going to cancel out, and 0x plus 30x is 30x. So now you're looking right here. Ooh, I forgot to drop down the 7, and I want to drop down that 7. So now you divide 30x by 2x, and that gives us 15. And you distribute the 15 to the 2x minus 5. So you get 15 times 2x, which is 30x, and 15 times negative 5, which is negative 75. Now you have to subtract both terms. So you're going to subtract here and subtract here, which changes both signs, and those cancel. And you're left with 82. 82 is your remainder. You go back up to your quotient and you add 82, but you have to put that over whatever you divided by, which in this case is 2x minus 5. So my final answer is 3x squared plus 6x plus 15 plus 82 divided by 2x minus 5. And that's how you write your answer. That's your quotient with the remainder. So a lot of your homework tonight is just you guys practicing long division and synthetic division, because eventually this is going to be applied to graphing. So there's one more type of problem that you're going to see in your homework tonight, and it's one like this last example. In this last example, it just says solve the equation. So you get to pick if you want synthetic division or long division. I give you the function, and I tell you that 1 is a root. Remember, another word for root is x-intercept, 0, or solution. So if 1 is the solution, and I'm going to pick synthetic division to work through this, I want to put a 1 inside the box. I do not put the opposite sign in here, because if I'm telling you a solution, then you put that solution inside the box. The example we did on the other side of the notes, I gave you a factor. When I give you a factor, you do the opposite inside the box. When I give you a solution or a root, you put that inside the box. If we're doing synthetic division, we have to list our coefficients in descending order, and we draw a line. We drop down our first term, and then we multiply that 2 by what's in the box. So 2 times 1 is 2, and we add our columns. 5 times 1 is 5, and we add our columns. 2 times 1 is 2, and we add our columns. Now what that did for us is it created a quadratic function, because this was 2x cubed, and since we divided by x, this drops down to be an x squared plus 5x plus 2. If you have a solution, so if I told you in this problem that 1 is a solution, remember another word for a root is a solution. If I tell you a solution, you must get 0 for a remainder. But we're not done with this problem, because this problem said solve the equation, and the equation was a cubic function. Right now, we only have one solution, and that solution is what we put inside the box, the number 1. So we have to find the other solutions now. To find the other solutions, we're going to set this quadratic equal to 0, and we're going to factor it. So 2x squared splits up 2x and 1x, and then 2 splits up 1 and 2. The 5x comes from multiplying 1 times x to get 1x, and 2x times 2 to get 4x. 4x plus 1x is 5x. So now we can set each one of those factors equal to 0. If I subtract 1 and divide by 2, I get my next solution. And then I can set x plus 2 equal to 0, subtract 2, and get my third solution. You can't forget to put the solution that they gave you in the beginning down as one of your answers, because you want all of your solutions together. So what I have in blue are the solutions to this problem. They're the solutions to the cubic function. But again, don't forget to include the solution that was given in the beginning as one of your answers. We're going to take all of this and we will apply it to graphing when I get back.